Good morning, good afternoon, good evening, everybody. Welcome to Automotive World. I'm Martin Carl. I'm the editor-in-chief at Automotive World, and I'm delighted to welcome you to today's webinar, which is entitled Alexa on the Road, How to Create a Voice-First In-Car Experience. We're going to hear today from experts from Elektrobit and Amazon who will explain how Alexa can extend vehicles' onboard capabilities. A little bit of background to what we're going to hear today. Voice recognition technology has come a long way in recent years to the extent that it even now is capable of interpreting natural language. As a result, voice control looks set to become a common feature of new vehicles, and that requires dedicated expertise. Elektrobit has proven its expertise in developing state-of-the-art voice user interfaces and is now expanding the reach of natural language technology with the integration of Amazon Alexa into the car. So over the next hour or so, we're going to hear from Volker Springer, who's Senior Project Manager at EB, and Ricardo de Matos, Principal Solutions Architect at Amazon. They're going to talk through a range of solutions that can help automakers to integrate Alexa into their vehicles. As usual, we'll have a presentation followed by a Q&A. If you'd like to ask questions, please type them into the Q&A box on your screen, and we'll address as many relevant questions as possible in the time that we have available. Slides and a recording of the event will be made available afterwards as well. We'll send you an email to let you know how and when you can access those. That's all you'll hear from me now. I'm going to hand over for Alexa on the Road, How to Create a Voice-First In-Car Experience. Volker and Ricardo, over to you.
All right, thank you so much. I'm Ricardo de Matos from the Alexa Automotive team. This is what we're going to be talking about today. This was a cockpit demonstrator that we did, that we were working together, and I think we're going to get a lot of insight onto how we use this as a medium to showcase some of the Alexa Auto SDK capabilities, what Alexa can do in modern vehicles, and also to give you a glimpse of sort of what we view as the future for vision of voice in vehicles that have some level of automation. So we're going to look at that. We're going to also look at how we work with Elektrobit as a partner to accomplish these goals, and also some of the challenges that we have with some of the scenarios that we introduced here.
Right. Hi, folks. I'm Volker from Elektrobit. As Ricardo pointed out, we designed and built this cockpit demonstrator, what you see on this picture, together. It may serve as an example, actually, what you might also achieve when using our services and solutions. Although Elektrobit is primarily a software company, we do also have hardware and designer expertise in-house, as you can see. So it's not only for POC like this one, but also for certified end consumer products. In this slide deck and in this webinar, we'll give you some insight on the technical solutions and on the concepts of this integration platform. And we'll dive also into the interfaces to the voice assistant or with the voice assistant. We partner and work with Amazon Alexa Automotive as we see them really fit to address some of the challenges we currently have in nowadays speech dialogue systems integrations.
Right, and I think some of the challenges that we have today is JD Power study that was done in 2018 really shows voice to be a pretty much a frustrating, problematic experience. So legacy voice systems that are in cars today, even newer vehicles, definitely tend to be challenging. They are problematic in using. They may even cause even more distraction as they don't operate very well under all the conditions. So we really want to change this, right? We raised the bar in a home. So Alexa really raised the bar in a home with how people interact with voice, how they get a lot of things done without letting go of the primary tasks that they're doing. And we've set expectations from our customers, and they're demanding the same thing in the vehicles. So we really have an organization now dedicated to looking at how we can bring that experience over into the car, which is actually a really different environment with some set of challenges.
Well, talking about challenges, the challenges in the car are actually plentiful. As we have, with our expertise and just history and actually running projects all over the places with speech integration, we have seen many of these changes, and those listed here are by far not all. So let's just pick a few of them. So probably the most prominent one is the technology advancement here. It means that we have different development cycles. In the automotive world, you usually have 4 to 5 years until you have a complete new car done, much less in speech technology. And especially in the last 4 or 5 years, also speech technology has gained dramatic boost in research in algorithms. We have seen now neural networks and machine learning, AI, just coming along, which was not available just the time before. So people also experience that, as you mentioned already, not maybe in the car, outside of the vehicle, but somewhere else. Another one is the complex integration. Like in a car, it's influenced by many different features, and the ever-increasing feature scope also of the vehicles is also paying a contribution to this problem. So the data handling needs to be addressed. So we need to look at address books, media, and so on. We have delta updates. Data consistency needs to be guaranteed. We have sensors in the car. That's also a big influence. And this needs to be somehow also even integrated maybe with different speech technologies. That can also sometimes happen, and that makes it even more tricky. Another one is the speech-controlled content. Even if we have a nice embedded system solution, the destination entry, for example, is somewhat a norm right now, yeah, but it's a minimum to fulfill. But people also want more. People are accustomed, as Ricardo pointed out, to control devices at home, to have their media somewhere. And the media also has a change or seen change. We don't have MP3 sticks with us all the time with our favorite music. It's a service. So it's a content which needs to be addressed. Variant handling, also a big challenge, especially for big OEMs. So we ran projects where we had several SOPs in a quarter. And these SOPs actually came because hardware components had to be changed because the higher manufacturer cost or reduced them. And hardware changes sometimes really from the lowest ECU up to the highest or possible top layer of HMI software. They are all affected by this. Because in the automotive world, we have extensive testing, usually, at least, done before a car hits the road. And therefore, it's very hard to keep track of all the different variances, even if the car looks outside the same. And, well, last, but for now, at least, is my favorite, actually. That are the languages. So what we had as a car or vehicle variant, we now have as a human variant, so to say. And that doesn't even apply to speaking different languages. It's also even within one language. You have different semantics. You have different idioms. English, as an example, yeah, or take Bavarian. In every little village, we have different words for the same thing, partly. And even now with different languages, it's very hard to translate that. So the inflections, for example, on certain words based on gender, number, and whatsoever. Then we have really bilingual customers, or maybe not even those who speak the two tongues, but it's just like the content also in our address books. Ricardo de Matos, it's not a German name. And so it needs to be handled in a good quality, and that is really something pretty drastic, even for humans. So it's actually, if you deep down or dive more deeply into that, it's really mind-boggling.
Yeah, so we didn't really address all those problems in our demonstrator, I think, but we also there were some that we basically get for free, right? A lot of the challenges that you said are problems that we actively are working on and solving for the home, and we get those but by bringing Alexa into the vehicle. But so what we wanted to do here is create an environment, create basically a scenario where we could showcase how some of those challenges could be addressed. Right, so let's take us to the hardware here that we're looking at.
Right, so this is a closer look to the device which we actually assembled. Like this cockpit demonstrator consists of several displays. It has a multiple screen setup. You see a huge 8K display in the front, which is used as information, and you have all the information at glance. Yeah. You have a control panel or a control pad, as we call it, for ergonomic remote operation of the system. It's close to the driver. It handles all the controls of the car's HMI and also controls the voice assistant. We'll come to that later. We have a steering wheel attached to the steering wheel, so it rotates as well. It's more or less used for autopilot and autonomous handover scenarios. We'll come to that later as well. The hardware is obviously requiring also a distributed HMI system. As you see, we used here, of course, we have projects running on automotive embedded hardware, but here we use the standard PC platform just to be able to do fast turnovers, to quickly adjust to new ideas and features. I mean, we talked just about this now, yeah? So how do we get the new technology quickly into this quickly into this platform? For the UI, we have chosen our Elektrobit Android framework, so we have a deep expertise in this field here as well. Linux is running here as well on hosting the background services. So it's a mixture of all the systems or operating systems, sort of like a hypervisor. Those systems are connected with the message bus. And on top of this message bus, of course, we need to have the audio. Audio is actually seen on top of this control pad. So we had a microphone array beamed to the driver, has a good noise reduction capabilities.
So this is actually a great challenge right to begin with, because we have multiple screens that need to work well in response to speech, right? So as you speak into the mic array, right, the voice chrome that's seen the line of sight of the driver or dashboard needs to light up, right? Needs to give them indication that the system is listening at that time. If they ask for media, we've got media cards that are shown on the dashboard. We got transport controls for the media playing that are accessible in the control pad for touch. So this is actually really interesting, because right off the bat, we have to work in a distributed environment, which it can actually even be on running different operating systems. Some are safety related, some are not, right? So this was actually great. Actually, one of the first things that you guys did is built on top of our SDK and made it participate in this message bus architecture. Mm-hmm. Yeah. So talking about the SDK, this is something that we introduced actually last year. Its first version was August of last year. We've iterated about once a quarter. We're about in the sixth release right now, where we have an automotive SDK that basically takes the existing Alexa voice service protocol used by home devices and makes it easy for automotive integrators to use in a car. We'll talk in more detail about those interfaces, but it also allows us to do certain domains in a specific way for the vehicle, right? So an Echo Dot in a house doesn't move that much, right? But a car does. So the navigation domain needs to be smart and give context for the responses that are coming back, so that they are not only applicable to where you are, but even to where you're going, which route you're following. So the navigation domain is something that we definitely focused on. The car control is a big deal. People are used to the voice and controlling the vehicle with their voice. So it was important that we provided a great way for them to do that, so that they don't have to actually get into the speech aspect of it and media. So the SDK, as I was mentioning, is available on GitHub. Actually, go to GitHub Alexa repositories. The SDK is there. It actually includes quick ways. You can clone the repo repository and get started with a simple app literally within minutes. And the sample app we actually provided in common platforms, Android and C++ based. But the SDK can actually work on an even greater set of platforms. And we provide build scripts that allow you to build it in kind of a very consistent way. Also to take the build instructions apart and include it into the pipeline for your embedded system. Those things are actually available to you, have been available since August and are available right now. In addition, as we work together with you in a proper engagement, we will make available modules such as the wake word, the local voice control, communications, that plug into this SDK and bring even greater capabilities to it. So specifically, what we're doing here is taking, in a way, the complexity of speech, right? The complexity of connecting to a speech backend that responds to actually a duplex conversation, right? Now, Alexa actually allows our service is able to send events back to the client as you're speaking. And the speech detection, for example, is something that we do, and it works really well, because we can tell the microphone to shut down when we have sufficient information or silence that came in. That is complex from a connection perspective. The SDK simplifies all that. And it also simplifies all that in a language that integrators can understand. So of course, when you speak to the system, it needs to know where you're speaking from, what the location is. So there's an interface for the vehicle to provide the current location where it's at while the speaking session is in place. There's an interface to allow the embedded navigation system to receive a lat long from an Alexa search result, for example. And interfaces for media player and recognizing sending audio and receiving audio. These are all great, but my experience in working with OEMs is that the existing vehicle interface, working directly with OEMs, is that the existing vehicle interfaces just were not really built with understanding for a speech system that combines all these things, right? With Alexa, you don't just get dialogues, you can get media, you can get control, right? You don't just send audio, you send context as well, right? So when we start integrating directly with OEMs, there's usually a challenge. There's usually a need to sometimes adapt these interfaces. And this is where it's really refreshing to work with Elektrobit because they understand. They're deep into these systems. They understand that, okay, this interface really needs to be adapted or combined or decoupled so that it can work and support that voice experience. So this, that's really kind of the benefit here of having a partner that deep understands the interfaces.
Thank you a lot. Yeah. But let's dive into the actually experiences. Yeah. So you just talked about experiences in the car, and I just want to shortly present what the story actually is. So we have seen the hardware, now we're coming actually to the software part. We have combined, as Ricardo pointed out, the ability to use voice with Alexa and also touch, like using the control pad, which you see in the bottom here on this just picture here. So we assume to have a daily commute. So a typical use case nowadays, an American roughly spends 50 minutes a day in a car, well, at least here in America, that's the case. So we anticipated also that in the future, maybe we have some highly autonomous driving modes. It's not there yet, but it's evolving. So we assume that autonomous is maybe available under certain conditions, maybe geographically fenced or whatever sensors may allow or disallow or just actually this autonomous mode. But then how should an assistant react? How should an assistant behave? This was our big story or big question here. And this is also one of the main reasons we did this demonstrator. Because in various drives modes, the assistant might actually have or needs to have a different behavior. It might even be required. And also, even apart from speech control, we had really interesting discussions about these assumptions with people we showed that. Just where should autonomous mode be? But in all, it's a typical use case. We start at home and go to a destination.
Yeah, I mean, I think, again, our presence, our deep presence in the homes, I think already also supports the use case that your trip begins even before you hit the vehicle, right? It is possible to build a skill for the home that supports your car, that has insight into your calendar and actually just ask the car to get ready. And the point of interest that you're going to can be sent to the vehicle. So that's exactly what we did here, is you prepare the vehicle from the kitchen, and then the vehicle has the point of interest that it's going to go. So that's actually worked out pretty well, and we'll continue the story within the car.
Right. So now that we are in the car, we actually drive along the route. We have integrated a full navigation solution here. We customized the display and its map styles actually to fit to the overall design language of the complete demo, much to the like to our HMI team. We have chosen a specific route, which for this scenario actually to be able to demonstrate all the various use cases we actually have with interacting with speech. So we have connected, as Ricardo pointed out, the Alexa Automotive SDK. Alexa knows where we are, and now you can do something like answering questions about nearest points of interest, for example.
Yeah, let's see that in action.
Alexa, show me Chinese restaurants nearby.
Here are a few nearby.
You'll get
Chinese
actually Seattle ones.
Asia ginger teriyaki and roll.
Alexa, is the second one open?
The Orient Express on 4th Avenue South in Seattle is open until tonight at 11 p.m.
Alexa, navigate me there.
Getting directions to Orient Express at 2963 4th Avenue South.
Yeah, so just want to highlight a couple of things that I'm not
sure.
sure if the audio was worked out here, but a couple of things that happen. So first of all, you can actually pace your own experience, right? So as you're driving or maybe you want to do something, you ask that question. We're not demanding you to do the next step right away. I mean, you might be in the middle of making an intersection or a left turn or something like that. We actually allow you to pace the experience and maybe get more information about the point of interest. So you found the point of interest, then you just wanted to know if they're open. And then at your own pacing, you say, just take me there, right? So I think it's important to be able to give that experience, a voice experience that doesn't pressure the driver into responding right away. We really we respect, right, that the primary task is driving, and we need to be able to support that in the driver's own pacing. That's really what the navigation domain is doing here in this demo. Yep. Yeah. Yeah, go ahead.
Yep. Mm-hmm. So, and actually with EB, you can do a little bit more. As we are also active member in standardization bodies like ADASIS, we actually have also solutions for map providers to actually integrate predictor solutions. So we look ahead, actually beyond the horizon and behind the line of sight of the driver to allow for energy efficient driving, adaptive lighting, and or just to give assistance to the voice assistant. And this actually brings us to the next bigger topic. So looking beyond the horizon really means the car sensors, the software stacks, hence also Alexa knows probably more than the driver. And somehow the driver must be informed by possibly upcoming events which are just on the road. And it should happen at the right time. It should also happen with the right amount of information in order to be useful for the driver. So the HMI or user experience has to be somehow accomplished that the driver gets, or that this incident gets the attention of the driver in a good way. And usually a simple bling or some cryptic LED or a simple LED might not really be enough here and sufficient. Neither would be a long text or big pictures, or which are hard to comprehend maybe in a given time. So all the information which needs to be conveyed should be done better. And we believe that speech is a good way for some of these incidents at least. And that also means that the assistant needs to react first. The assistant needs to come up with a dialogue, needs to maybe request answers, so engage the driver into a conversation. Alexa does not really deliberately provide that solution right now, here at least when we integrated it. But we solved it with a little trick. So we had some silent triggers actually to get really Alexa responding first. And we had to, of course, modify also the HMI so that the Alexa Auto SDK and didn't request at the right time that a chime was just played or something like that.
I mean, I think the bottom line is that OEMs understand a lot about their vehicle, right? If they're using suites, eHorizon suites and some of the other advanced technologies, they really understand not only what's in and around the vehicle, but what's really ahead of it. And they can add those capabilities to Alexa skills. And those skills can be invoked either through driver speech or through system events. And that's what we showcased here again, painting a vision going forward.
Okay.
Yep.
So we can also show you what I mean actually with a proactive dialogue engagement. We have a proactive handover dialogue here.
Autonomous drive is available for the next 18 minutes. Do you need help on how to enable it?
Yes, please.
You can start autonomous drive by pressing and holding both buttons on the steering wheel.
So now, as you can see, I'm still actually in charge of the car, but I want to actually hand over. So I do that by pressing both buttons. One isn't enough, as you can see, and I also need to do that for a certain time. And once I have done that,
your car is now in autonomous drive. I'll let you know when you need to take over. Enjoy the ride.
Yeah. So basically, what we have is the system. As you reach a certain waypoint where autonomous drive is available, we send a system event that starts the skill and engages the driver in because this is very forward-looking, right? The takeover time or the reaction time here, because of the sensor technology, gives the driver, minutes, single-digit minutes to react. So we can engage in a dialogue. We can also abort the dialogue in case the system does go back into manual mode. So again, it's really interesting to be able to showcase this idea about bringing the assistant in to give context into automated vehicles that have very long takeover time requirements for the driver.
Right. I mean, here we had done something like an incident out in the road, but where could else an incident be?
Well, so a good example of that, so if you have an Alexa device in the home, you can actually set up this feature called Alexa Guard, which allows the embedded wake word system to listen for glass break or smoke alarms. So you actually get a notification that that such event was detected, and then you can drop in. And that notification system is actually available to our ecosystem, right? So we provide frameworks, whether it's skills development kits or device SDKs, to allow folks to really come up with ways to control the home, to monitor the home, and to act upon that information. So the proactivity scenarios that we did, in this case for road incidents, they can very easily be leveraged for other things that cause anxiety while you're driving, like something happening with your house. And we can leverage that not just in a very specific, brand, but in thousands of brands. We hit 100,000 skills last week. Actually, it's a great milestone. So that level of interaction really gives you reduces the anxiety as you're driving, and if something does happen in your house.
Right. This is actually a good answer to the content challenge I recently mentioned. Yeah. So it's great to have a framework which is extendable, which is open to anyone who likes to contribute actually to provide content via speech. So actually doing this and connecting this to your home, this was something what Ricardo mentioned. We have done that. We have integrated the Alexa environment into the car. You can access all your Alexa skills, but we wanted to take it a bit further. Like controlling the devices, it's more or less for granted. You get it when you integrate the Alexa Automotive SDK, when you do it by voice. Yeah, so controlling your thermostat, getting maybe some information on that, it's all done voice only. However, in this cockpit demonstrator, we wanted to also provide a video stream. So to, for example, show the doorbell. Yeah, so in the video, we could really say, Alexa, show my doorbell, and you got a video screen on the big cluster, on the big dashboard instrument, which showed actually who's at your door.
Yeah, so this is actually pretty cool because we're able to, and we'll talk more about this, but knowing when the vehicle is in automated mode, we can show a lot richer content. In this case, the cloud cam. Anybody that has a cloud cam can use voice to show it.
That's a perfect handover because if we have a video stream, why not using it for something else other than the doorbell?
Right.
So we actually integrated a video entertainment system, which allowed you to watch Prime Video experience just like on a Fire TV. And in fact, it was a real Fire TV device, which we plugged into the hardware and which we controlled by our software. And we'll see more of that. But video is, of course, not the only part of the entertainment system here in the cockpit demo. Music is the other. So we use the Alexa Auto SDK's media player control. Also on the control pad, we were connecting it to this one, and we have the full media player experience more or less for free, as long as you stream with Amazon Music or elsewhere by just other music services. You could, of course, still control that by voice.
Yeah, I think it actually is one of the huge benefits, right? Because when you engage with us with Alexa Auto, you bring essentially all the music service providers that folks are used to in the home. So we have support today in most platforms.
Or whatever, right?
Yeah, so TuneIn, iHeartRadio, Pandora, as well as Spotify for certain platforms, and Amazon Music and Audible. Again, a single experience brings you all those media players and services that people are used to. So it's quite powerful and actually saves the OEMs a lot of times.
Maybe just look at the video.
Yep. Do that.
Trying to get the audio now.
Yep.
Now I can do some things like, Alexa, play the Grand Tour.
Here's what I found.
As you see, Grand Tour is not auto-resuming, obviously, and she only suggests the search results. You have a Fire TV remote control.
You see in the middle my hand covering actually the remote control. This was, again, the control pad communicating over a system bus with the Fire TV controller, which was somewhere in the back of the car here,
Sure.
and which displayed then the part on the control on the dashboard.
Yeah, I mean, I think what you're seeing here, first of all, is something that already exists, right? So today, if you
Right.
have an Echo at home and you have a Fire TV stick or Fire TV Cube in your home, you can control, those things are linked and they can be controlled with voice. So you don't have to go find that remote control. You can just tell your Echo to control the Fire TV. It's exactly what we did here. We brought that concept to the car because this car is, kind of forward-looking. This concept is forward-looking, and it allows for a video experience. But at the same time, we wanted to showcase the ability to do voice for controlling the content, searching the content, which is supported again with the Fire TV and Echo devices, as well as the ability to actually physically touch the controls, the multimodality. And again, this is a concept, right? The Fire TV team itself is working with automotive OEMs as well to bring a more specific solution into the vehicle, but this is a great way to showcase that voice-first experience for video.
Well, video is one thing, audio is the other. You mentioned something like audio stream handling here. It was pretty tricky. You mentioned the devices are connected in the cloud together on your account, so to say. But the audio handling and the output is specifically is distinctively different from the Fire TV concept than the Auto SDK currently provides. So
that's true. I mean, these two devices, right, in a
Right.
home, when you talk to your Echo, the Fire TV doesn't pause.
Right.
But here we brought them together in a vehicle. We had an Alexa endpoint and a Fire TV endpoint talking in the same audio system. So that posed a challenge, right?
So we had to think about what do we do? Do we integrate some audio management, some proper audio management with level shifting and whatsoever and prioritization? Here we actually made it a bit easier, and we gave Alexa the precedence and paused Fire TV with a software solution while Alexa was actually busy or just announcing something.
And I mean, the approach is simple. You can either duck the audio or you can pause the content, right? So our SDK pauses the content if you interrupt the media experience. And we applied the same thing through the Fire TV experience. Okay. So that's a good explanation there.
Alexa, play the Grand Tour.
Sorry, video watching is not safe while driving manually. Please start autonomous drive mode first.
That's a different solution, right?
Yeah. So I guess again we're having some audio issues, but the challenge here was that we try to do very engaging content, watching video while the vehicle was in manual mode, right?
Right.
Yeah.
So actually, that means that we need to have somehow control over what happens in the car, even if the device maybe is in the cloud and also the assistant has no knowledge about the car. So that brings us actually to the part where we implemented driver workload management. So video during manual drive obviously is probably not a good idea. Hopefully everyone agrees. So what we wanted to have is really something which is possibly, again, available in the future. That's the reason why we integrated this into the platform. Again, we had great conversations of what should be allowed during driving and what not. And the video sample, what we showed, is again something which is required a process in the car, not in the cloud, to control what is happening. So we introduced a layer in between the Alexa Automotive SDK because we can connect those sources. We have our solutions and frameworks here. I already mentioned eHorizon, but we also have the car sensor data like AUTOSAR driven, or we even have cyber protection states which we can actually access. All this kind of information, including the cabin information, like driver monitoring systems maybe, or environmental data, like let it be the weather or traffic conditions, they all maybe influence somehow this. And what we see from our experience is that these are really much related and that they need to be aggregated into a central piece in the car, in the embedded system, which actually influences the behavior of the assistant. That's also the reason why we at Elektrobit provide a concept and also tools for actually an ontology-based rule or dialogue specification system.
And the important thing is that context is key, right? I mean, we don't want Alexa to be a nanny in a vehicle, right? If the driving environment is correct, right, we should be able to deliver that content. But the driving environment changes. I mean, it may not be accurately reported to the cloud due to connectivity issues. More on that in just a bit. The interesting approach that Elektrobit took here is that they know the context of the car. They know exactly what the sensors are doing locally. Right? And even without reporting that to the cloud, even without reporting that to Amazon, they can make decisions on what content is most appropriate. They can block, defer, pause, or just let it be played. And I think that is, ultimately, and we support this as Amazon, the OEM has full control of that experience to protect the driver from distraction. And we're able to, Elektrobit was able to create a new module, a plug module into the SDK, that can analyze the state of the vehicle, in this case, just autonomy on or off, could be more, and make an appropriate decision to deliver immersive content. So really well done here.
Yeah. So we mentioned data sources here might also come from the cloud. So I think we still need, when I talk embedded and have some local solutions actually to work on this, just differentiation of what the assistant or how the assistant should behave. This might still be influenced from the cloud. I mean, not only from the content, richness of 100,000 skills, and that kind of but also something like for the media or music experience. Yeah. Right. So the cloud is there. Is it there?
Sometimes. Right. Connectivity is actually doing really well. I think if you look at, this is actually a snapshot of a study that I did 2 years ago, but still relevant, of a vehicle using a specific cell phone provider driving away from where in this case, one of the data centers were. Right. So two things you see here is that latency increases as you go further away and have additional hops to get to the service. And although we do the latency, the system is not necessarily latency sensitive, but that is a fact, right? There might be some specific messages that could be sensitive to latency greater than, let's say, 300 milliseconds. And the other thing that's really important is that connectivity is just out. I mean, if you look into the data points, especially here in California and some state park roads and stuff, it's just no matter which provider you have, it's out. And the vehicle is designed to work there. So we have to make sure that the voice system also works during those scenarios. So what we've done is we introduced basically a module to the SDK that gets plugged in, and it is able to process the audio and do automatic speech recognition, natural language understanding, and some degree of content providing locally, right? So, of course, car control is something that people expect to work all the time. So if they are using the system to modify climate or change driving modes or whatever, they want that to work regardless of whether or not they have the connection. The ability to switch sources, the ability to dial contacts if you still have that weak connection on your phone. The ability to get to favorites on your that have been saved to your navigation system. Kind of the table stakes of voice assistants today are available with Alexa with or without a connection. And it's a nice little module that can be plugged in into the existing SDK, and the SDK itself has the smarts to know which system to use and which system to pay attention to given the level of connectivity and the intent that was asked.
Alexa, set the temperature to 75 degrees.
Okay.
Yeah, one thing that we missed, and again, we will give you guys links to these recordings, is the fact that in this case we have a system. This demo, Buck, we actually had the ability to cut the internet, go into what I call airplane mode, right? where we physically cut the power to the routers in there. And Alexa detects that state, and it still does its work. And it's able to actually do it fairly quickly, even without an internet connection. So we'll show that in some other time.
And we even actually took care for that, just like internet loss, by actually introducing some kind of state handling or just connectivity checker in order also to reflect this on the HMI.
Yeah, I mean, that's the challenge, right? Because I think the system is still operational, right? But it's in a degraded state. And we had, this is where kind of your HMI experience comes in. We had to communicate that to the driver, say, hey, the system is active, but it's at a degraded state, and it can still do things, but don't try to do cloud things like, opening your garage door, right?
So coming back to the local voice control, that was actually not available at the early integrations we did with your SDK.
Yeah, back last year, that's true.
Back last year, you mentioned it. So we still had a voice control possibility for that, just by actually using an AWS IoT device in the car. This was working well, at least for the temperature control, and now Alexa or the Auto SDK was equipped with the local voice control. So we had to do a software update during the course of this demonstration platform. And actually, it was really a breeze. It was pretty easy. There were just a few actually interfaces to be changed. And we still have the code for the IoT stuff in there. Who knows? We might be using it.
So the idea is that we have a couple options, right? So we do allow some interfaces to be controlled locally, right? And the language model that supports the local control is you can configure that. You can configure that to discover. Maybe you have a rear seat, or maybe you don't, right? So those things are configurable. But the extent of which you probably want to allow some aspects of the vehicle to be controlled via cloud APIs. And this is where AWS can come in, and through it's the services that it offers, it can expose some aspects of the vehicle, whether it's in the data collection or even control aspect of it, to the cloud, and then the skills developed in the cloud, like it did on the first version, can control that as well. And the good thing about having a cloud endpoint that controls aspects of the vehicle is that that control can be done from the home. So vehicle conditioning, sending POIs to the car, those are all great examples of things that you can place in the cloud and control from various devices.
Right.
Yeah.
So you mentioned already the little details like this Chrome, which is appearing maybe on the dashboard, and control over there. So that actually brings us more or less to the end now, because we have seen now it's also the little details which make really a compelling HMI. And maybe just allow me at the end just shortly introduce Elektrobit for those who might not know it. I'm or just sometimes at least misrecognized here as a small startup here in the Valley, and I'm asked questions like for financing, which I can't answer. We are actually part of the Continental Group, but we are actually an independent subsidiary. Global company, automotive software, more than 3,000 people worldwide, actually on every continent where cars are built. And apart from what I mentioned earlier in the webinar, we have also software development expertise for automotive. So results in project consulting, execution of testing and verification support. We offer automatic driving support, like for ADAS, and highly autonomous, accurate vehicle positioning. And we have also OTA solutions. But last but not least, we have really a user experience group and have a tool around that, called EV Guide Studio. You can find this on the web, where you can conveniently actually model your UI as well on the PC and deploy to the target faster. And most importantly, our speech team here is really having a good and new approach to that modeling of this complexity and trying to increase the productivity for our customers and also for our internal speech projects, actually when it comes to integrating this. So as a baseline, EB can help you to tackle those challenges in the automotive software development, not only for speech integration, but mainly, of course, for speech integration. And I think if you want to know more, just how you can actually engage us, just get in contact with us.
Yeah, we can leave this up here because it's really important. If you go to Amazon.com/Alexa-Auto, you're going to have there links to, well, first of all, you get to see all the customers that are using us, both from the skill side and device sides, which is great. You also get to links to GitHub, as well as the automotive guidelines. We talked in a lot of detail here, like some of the decisions that were made. Those were grounded decisions based on the guidelines that we have published. So you can Google or go to that link, Alexa Automotive Guidelines, and actually see what a point of view that we have on how to bring the voice experience visually into the vehicle. So we encourage you to go there or get in touch with us directly as well. But I think we can open up for some questions now.
Right. Yeah. I think we're good. So thank you for listening.
Yeah.
Thank you very much. This is Martin again. Thanks for sharing all that insight with us, and some great demonstrations there as well. We've had a number of questions come in already. If anybody else would like to ask a question, please type it into the Q&A box on your screen. I'll put them to our panelists now. I'm just keen to know, you both very casually mentioned the way this has all been developed and brought together as if it was something very simple. I just wonder if you could, without getting too technical, certainly not for my understanding, was it that easy?
Yes and no. So as already mentioned, we have our history in speech integration. We came across a technology where you really had to fiddle around with the low-level drivers, low-level integration of a speech recognition system, partly even running parts of it on a DSP, the other one on an ARM processor. But all this kind of knowledge actually gives us at least some understanding of what is actually behind the presumably easy interface, or just the simple and lean interfaces Alexa provides. Sometimes we would have loved more because we want to have more challenges. So I think we pushed it a bit to the limit, partly. On the other hand, we know for sure, and also from experience, like there are good people working on that. And
yeah, sure. I mean, there's definitely thousands of people working on the problem, but in a way, it's, you know, the car is definitely a very important space for us, but we're in many other places, right? So from a speech perspective, it was actually pretty easy because you got all the capability, right?
That's true.
So the normal areas where you'd focus a lot of your time and you figuring out the dialogue, the responses, all that became nearly instant and simple. Right? Yeah. But we still had the challenge of, like, we've got the speech system that now wants to do media, do navigation, do calling. So that integration became the required understanding of the interfaces. Right. So it's not like a more difficult problem. In a way, it was just a different type of problem then. Yeah.
All right, thanks. I mean, I've got a question for you, Ricardo. Feel free to both chime in here. But I'm wondering if you can just give us a bit of a outline of how different it is to work on speech recognition in a car than it is to work on speech recognition in a home. Obviously, in a home, you might have anybody positioned anywhere within a room who's talking to Alexa. In a car, you've got four usually people in very fixed positions. So you know where they're going to be sitting, roughly where their heads are going to be pointing. But in-car is also possibly the harshest environment for voice. So you've got that additional challenge, despite the fact that you know where the people are, of the sound coming from all around that is white noise that interferes with those people's otherwise very static communication with Alexa.
Yeah, that's a good question. So it turns out actually the problem is even worse in the kitchen, right? So there's a lot of things, especially in my kitchen, going on, and the fact that Alexa still is able to be informed to the person that woke up the system and just listen to what is being spoken there is actually amazing. But it does require the advancement of the audio front-end system, which a lot of the times we don't have control in a car. We have control that on our devices. We have control that with partners that want to listen and build wake word and front-end audio systems that do very well. And actually some vehicles do it differently. I've worked with cars before where they purposely cancel out the audio that's coming from the passenger. Well, the passenger in my vehicle happens to be a big fan of Alexa, right? It's my daughter. She absolutely loves to use the system. And she does so in a polite way, so it's not like super distracting. But the idea that audio front-end systems that were very driver-focused, they have to adapt to what is now a communal system, right? People in a car like to use it. And so the challenge here is really getting those front-end audio systems to understand the challenges of running a wake word and doing it well. And I think right now, for example, we have the ability to fader and go back and left and right and balance your audio output. You could argue that a similar idea is going to be needed for the input. And we have to work with partners in the audio front end to kind of define what that user experience is like, so that whoever is waking up the system is the right person that you want to. That's kind of one of the challenges. I think it's less so on a noise reduction perspective. It's kind of a solved problem both in automotive and even in a house. Now, the issue is how do we bring additional people at the right time into that conversation? And of course, to drill down on one more challenge is that because we're touching a lot of the experience, the challenge sometimes can just be figuring out who all those suppliers are, right? I've worked in, for example, media certification issues that we're literally, had 3 suppliers on the phone trying to figure out where the behavior was coming from. So I think if we this is important to understand not only in depth about the technology, but be able to quickly navigate to who the stakeholder is so that we can adapt quickly. I think that's the challenge. Coming from an organization that builds their own devices, that works with home devices, moving into automotive, you have different audio front-end systems and various stakeholders that are touching the systems that you depend on.
All right, so we go from the challenges of the harsh audio environment to the challenges of language. There's a great question that's come in from the audience. Does Alexa have an offline SDK, and what features will it support? And does it support any Indian regional languages?
Yeah, so that's a good question. So the features that have been released in SDK 2.0 include navigation, so the ability to ingest an address book and go to that if you're offline, the ability to call, communications, as well as control the phone experience, offline, right? As well as to be able to discover and control devices in the vehicle that of type power controller, range controller, and mode controllers. Those things are there on offline. The offline work that we do trails the online work that we do from a language perspective. So we are working on bringing in the full Alexa language support that's right now on the online system over to offline. So this is a good, if you want more insight on that, get a hold of me through the email I shared, and I can give you guys more detail on what the timing is for that. But we definitely have, people definitely want to see not only our full set of languages to expand online, but also for us to catch up and bring those models over to the offline case.
All right, this might, I'm not sure if this is a duplication or if this extends that topic. Somebody's asked what capabilities are available offline for Alexa if the vehicle has no wireless or cloud connectivity?
Yeah, it's about the same. I mean, it's again, navigation, communication, control, and also media selection to be able to tune to a station, switch media sources, and those things are available as of SDK 2.0.
On the topic of language, is Alexa in English and Alexa in a Chinese language? Is that 2 different Alexas, or are there underlying coding areas which can overlap so that you can share some basic expertise?
Yeah, so we abstract the language processing away from the implementation, right? So the vehicle implementation has to do 0 language from that aspect. Because at the end of the day, what the interfaces in the car get, they have an intent or an action, right? Which is not in any, it's not really spoken language.
It's not even an intent. It's really a callback.
A function call. That's right.
That's right. Here in
yeah.
this
So there is no. So from a vehicle interface perspective, there is no changes. This is actually nice because you can enable languages as we enable them. You can enable the language support online, right? So that is quite beneficial. Now, there are some details. Of course, the HMI that you built to be able to support the visual experience, we're going to ship the visual experience in the language that you selected, but maybe there's surrounding HMI that needs to be able to adapt as well. So, but it is very low effort to be able to adopt a language that we support. If you're using offline, of course, you're going to have to push those models to the vehicle. The incremental model is actually quite small. But if you're online only, that can actually be a transparent update.
Thank you. There's a great question here about capability now. How do you determine which Alexa skills are appropriate or inappropriate for in-vehicle use?
Yeah, that's a great question. We actually get that a lot, right? So our position on Amazon's position on it is that we are working with skill developers to be able to flag the skill for automotive use and be able to work with them in a tighter certification process. But ultimately, and this is the important part, ultimately it is up to the OEM, right? The OEM has the ability to control ultimately control that experience from a driver workload perspective that goes into the vehicle. And we're very flexible with that. So I think we definitely want to hear specifically what are sort of the offenders, and then work and maybe even use design patterns like Elektrobit introduced to be able to, given the local context of the vehicle, block or defer or cancel that experience. We really listen to the OEMs. We trust them in this space. This is an area that they've had dozens of years in testing and understand the regulation very well. But we want to give a kind of a starting point that they can pick from a workload perspective.
I think this is an interesting aspect, like what you mentioned, like regulation bodies. Maybe they also even have to jump in at a certain point, like what should be allowed in the car and whatnot. I mean, we have seen that at least in Europe that lots of activities during driving are not allowed. Right. Yeah. So maybe this might even actually influence some of the skill development later.
Yeah, I mean, definitely, we're open to get that feedback. If we need to influence the developers of the skills, we will certainly do that. Skills that we own in the first-party domain, those are being, adapted to the car. But ultimately, it is the OEM's call to be able to decide if that experience is too much for the driver.
All right, this might be something that both of you can take from your own perspectives. What type of hardware is required for local speech processing? And the questioner has cited, for example, CPU, RAM, MIPS. How big are the models? Yeah, so they are larger than the online solution, right? So this is actually a question that I would rather take through offline, through email. If you guys could send that to me. What we're doing, we've currently set targets for the offline experience. Knowing that, we two things that we want to do is add more capabilities and also reduce that target. The specifics of that and what those numbers entail is something that I can share with you guys over email. But they are larger than the online solution, but you would expect that because you're doing ASR and NLU locally, skill resolution locally. But they are within the bounds of what you'd find in these upcoming systems that we're dealing with. We're really working with OEMs today to understand what the limits are, and we also give flexibility. So the cloud SDK or the client per se can actually run if it's well connected in a separate board than the local voice control system. So that gives you the ability to run processes where there are resources, provided you have a low latency way to get to them. So there's flexibility on the placement of those services. They don't have to sit in the same process, and we're working with OEMs to understand how to trim that down while at the same time giving more natural language understanding capabilities to the service. We've got a number of great questions coming. I hope we're going to get through them all. But this one, I wouldn't even have thought of this, but I'm really pleased that somebody's asked this. How do you react when multiple Alexas are active within the car, such as, for example, one on a phone app and one on another device?
Yeah, that's a great question. We caused that problem. So 4 years ago, I was part of that problem when I introduced the Ecobee thermostat into homes that had Alexa devices. And what we do is we calculate the energy of the sound that's coming. So again, assuming they're logged in with the same account, we're able to calculate the energy in the cloud of the sound that is coming from both devices and pick the one that is highest. That's one approach. There might be some other approaches that we use there, but basically the signal that is strongest wins. And because the devices are connected both ways, we will send a stop capture. In other words, we will tell that lower power device to shut down and allow the other one to take over. This is the beauty of having the SDK, because that connectivity is there, and it's there for a reason, for this very scenario that you mentioned. Great to hear that we have that problem in the car already.
It's sort of the same like with the Fire TV, right?
Right. Yeah. But if they're under the same account, the signal with the highest signal wins, and the other one is shut off by the cloud.
Do you think that Alexa will recognize the voice of a driver unlike other passengers? And the question is put this specifically because when it comes to autonomous vehicles, how will the Alexa system recognize who's sitting where and who takes priority with communicating with Alexa?
Right. That's a great question. So today we have the ability to recognize voice profiles. But what we do with the voice profile is actually personalize the experience. So for example, if I say play music, or my wife says play music, we actually get different tunes, right? But we're not blocking access to features, at least not yet, right? There's other assistants that will actually use your voice fingerprint to like not show you pictures, for example. That's not something that we're doing. But one thing that to keep in mind, we're not blocking OEMs from doing this either, because you might say turn up the temperature, and the vehicle gets back turn up the temperature intent, and the vehicle locally can decide, okay, which temperature should it be, right? So before you just turn up the global temperature, you might say, well, the airbag sensor or the seat pressure sensor indicates that there's only a driver present, and it's an EV, and I want to save energy. I'm just going to turn on that specific heater zone. So you have the power to add additional smarts into how you implement the climate control interface, for example. And that smart doesn't need to depend on Alexa. It can depend on your local awareness of where speech was detected, maybe direction of arrival, maybe other sensors that you have there. So even without Alexa supporting that, you can actually have a lot smarter implementation of those commands that are driver aware. But we are working on voice profile. Actually, we just opened up the preview that third-party skills can leverage that voice profile information. But again, voice profile in the approaches that we have today is to personalize, not block experiences.
Can you talk about safety issues? We've had a question here which addresses safety issues specifically. Are you facing any safety issues when accessing safety critical information in the car, such as, for example, interacting with ADAS technology?
Yeah, but this is where this demo was not really just focused on. I mean, this also the ADAS information is not, or the HMI part is not part of the ADAS software stack. So we clearly need to separate, I guess, the HMI and also the assistant part away from the critical functions where you have really also other software development processes to follow. And so the information which we actually obtained from ADAS or from the system were filtered. So it's not the full-blown connection to the ADAS system.
But to be very clear, right? If you look at the car control module that we ship with Alexa, there's no intent at all there to be able to touch things that are not in the infotainment system, things that are safety related. We're pretty clear about that because we understand obviously there's complexity in that space. But it is something that we're willing to entertain in demonstrators for sure. And even as we start looking at the local solution, there might be other alternatives there to still use speech, but use speech systems that the OEMs feel comfortable with that interaction. But it's not besides demonstrations, as we mentioned here. The SDK is really designed to do things that are accessible on the infotainment system, such as climate and typical controls.
All right, final question for you. I realise we've slipped past the top of the hour. The wake-up word is something that the OEMs want to customize. How easy or possible is it to do this without using Alexa as the wake word, or will you always insist that Alexa is your wake word?
Okay, there's a little breakup on the audio here, but I do understand the question. It's the question around the wake word. I think it's first and foremost important to understand the technical bottom line is that we support multiple, the SDK does support multiple wake words. That's the technical aspect of it, okay? But we have to understand it from a user experience perspective. So I did roll out a system that had multiple assistants in there, and we have to know what is the value of this wake word. Is it bringing a separate experience? Is it bringing a separate voice? If it's a separate experience, will users know to invoke a certain wake word? Right? But really, the challenge that we have here, again, we started at the home, and we want to bring this home, really awesome, rich home experience that we have, voice experience that we have in a home, into the vehicle. It needs to be recognizable. And one of the biggest most recognizable things about a voice experience is how you invoke it, right? So I do respect the fact that we want to brand and differentiate, but we must not confuse. And I think we from a technical perspective, there's support in there for that. And we are, there's something that we can engage in more discussions with, is to understand the use case, to understand how your solution will not lead to confusion or dead ends. Because if whether I invoke the OEM wake word or the Alexa wake word, we should not require the drivers, especially the drivers that are driving, to think about what assistant to invoke.
Ricardo, Volker, thank you very much for sharing all that information with us. Thank you for putting together that presentation. We do have to wrap it up now, so I'd like to thank everybody who's joined us for today's webinar and sent in all those questions as well. I got through as many as I could in the time that we had available, but as Ricardo has mentioned already, please do get in touch with him after this event if you need to. His contact details will be on the slides that will be available for download. We will send you an email to let you know how and when you can access those, as well as an on-demand recording of today's event. And with that, I'd like to draw today to a close. Thanks very much and goodbye.
Thank you.